As data creation, capture, and utilization continues to grow exponentially, today, more than ever, businesses require a flexible data architecture to successfully manage and access their data efficiently and cost-effectively. There are many challenges facing data system architects, like bandwidth and latency concerns, CPU over-provisioning, and the excessive costs when it's time to scale capacity. This is precisely why Seagate has embraced the Composable Data Center architecture model. To better understand the Composable Data Center, let's first review how traditional data centers are constructed. In the traditional data center model, scaling capacity means attaching additional NAS and SAN systems to the network. As additional storage units are added and larger data sets are moved between applications, the main issue becomes quickly apparent: constraints on bandwidth. To address this, many data centers have adopted the hyper-converged data architecture model. This model places clusters of commodity servers together, enabling each instance the ability to manage and analyze larger data sets by placing the CPU and other resources, like storage, GPU, and memory, together. This model also enables the use of hypervisors like VMware, Xen, KVM, and container orchestration software like Kubernetes and Docker, allowing for the creation of container clusters and virtual machines. This provides increased provisioning of CPU and storage resources within the individual server nodes. Though more efficient than the traditional model, a new challenge is presented. Each CPU now functions essentially as the gateway or bottleneck for all other resources within its cluster. When busy managing tasks, the CPU cannot effectively serve its local underutilized resources to other nodes across the data center. The result is suboptimal resource utilization, poor scaling efficiency benefits, and unpredictable performance issues. Additionally, this model assumes unnecessary but required costs when hyperscaling. Under the hyper-converged model, resources are fundamentally tied together. When you need to scale one resource, such as CPU, GPU, storage, or memory, the others must scale as well, even if they aren't required. So, what is the solution? This brings us to the Composable Data Architecture model. This model views each individual resource, compute, storage, GPU, and memory, as an elastic resource or an atomic building block, giving both developers and organizations the ability to deploy, adapt, and modify them in real time. This also opens the door to defining resource-specific virtual appliances that are easily and readily shareable for use across the data center, so the right resources can be paired to the right processes dynamically, regardless of where they are located in the physical infrastructure. The composable model addresses the shortcomings of legacy architecture models by addressing bandwidth and latency issues and bypassing the problems presented by CPU over-provisioning. This is solved by the introduction of streamlined standard NVMe driver connectivity that do not require CPU interactions, the emergence of memory-centric fabrics with ultra-low latency capabilities, allowing connections to extreme latency-sensitive composable devices, and the standardization of control plane APIs, like CSI and Redfish, that make it possible to avoid customized translation layers that require CPU translation overhead. This framework addresses the latency issues found in older data architecture models and bypasses the problems presented by CPU over-provisioning. The result is a highly efficient and scalable data center with an optimal cost structure to meet hyperscale growth. For over 4 decades, we've been listening to and working with customers and partners, helping them extract the maximum value from their data. Today, we are hard at work creating new data solutions and optimized hardware and software that will enable the composable data center of tomorrow.